Alright, today we're going to start curve sketching, and what that is we're going to take all the things that we've learned in this whole unit and we're going to create graphs from them. I'd like you guys to take a look in your book at page 202, analyzing the graph of the function. Just take a look at that page, and also I'd like you to look at page 204, how to find a slant asymptote. And what I want you to take note of is that slant asymptotes occur when the rational functions having no common factors, degree of the numerator exceeds the degree of the denominator by 1. What does that mean? Well, let's go ahead and use this example. Notice how the numerator's degree is 1 higher than the degree of the denominator. So there's a chance for that slant asymptote to occur. This is what a rational function is. It's a fraction with two functions being divided. How do you find the slant asymptote? Well, the way we find slant asymptotes is using long division. So I am going to go ahead and divide these two functions. So I will say that x goes into x squared, x. So x times x is x squared. X times negative 2 is negative 2x. Then what I'll do is I'll subtract this off. And when I do that, I end up just getting 0. But I have to bring down this 4 yet. So what I'm really thinking about is just how many times x goes into 4, which it doesn't. So if you remember anything from Algebra 2 and your long division, you would just say your answer would be your, I can't think what that's called, the remainder over the divisor. Sorry, I couldn't come up with that name right away. Where the slant asymptote is just this part that I divided out. So our slant asymptote would be y equals x. So that would be this line of a graph. Okay, in this problem, the main things I want to get through are the first derivative and second derivative. And while I would love to get through all the rest of this, I don't know if I can in a 5-minute video. So we're going to see how far I can take this in the 5 minutes I have. So I have first derivative be bottom times the derivative of the top minus the top times the derivative of the bottom all over. Notice it's just a 1. I didn't even write it. Bottom squared. Well, in order to simplify this, I'm going to have to multiply. So I'll have to FOIL the first part. And I'm just writing everything. I'm not really stating it. Minus x squared plus 6x minus 12. Or minus negative 12, excuse me. All over the bottom squared. What that ends up giving me on the top then is, once I combine stuff, I have an x squared. I have negative 14x and a positive 6x, so it's negative 8x. And a positive 12. On the bottom, I would have critical numbers of 4. And on the top, I will have to solve. So I'll go ahead and start my first derivative test line right here. On the top, I can factor into x minus 2, x minus 6. So that means when I set this equal to 0, my other two critical numbers will be 6 and 2. Testing the interval. I'm going to test this. Let's put 0 in for this right here. I'd have 0, 0, positive. Okay, over positive, everything's squared. It's going to be on the bottom positive, so it's just going to be positive. Let's see, 3 in there would give me 9. Minus 24 plus 12, that would be a negative value. 5 would be 25 minus 40, which would be a negative 15. And then I'd have plus 12, which would be another negative. And you might be asking why that can happen. Remember, there's really an asymptote right here at 4, because that's what gives you undefined at the very beginning. So we might as well go ahead and write that while I'm thinking about it. So we have a vertical asymptote, but x equals 4. Then we also have, when we plug in 7, we would end up with a positive value here. Let's go back to these asymptotes real quick, because this was the other part of this problem I want to talk about. There is a slant asymptote in this one because there's 1 degree higher on top than there is on the bottom. The way I would find that slant asymptote is by using long division. So I will divide these two out, and I'll get x. And then I left the other part off here. So minus 4x, subtract this part off, which gives me a negative 2x when I distribute that through. So I'm adding negative 6 minus negative 4 is negative 2. And then I would say that negative 2 goes in there. So I get a negative 2x plus an 8. It really doesn't even matter what I'm left with in my remainder. My my slant asymptote would be y equals this portion right here, x minus 2. Since I'm kind of going all over the place with this problem, I'm going to go ahead and put some of these things in here. I have a slant asymptote at x minus 2. So that means it has a y-intercept here, and that goes up 1 over 1, up 1 over 1, up 1 over 1. So there's my slant asymptote. My vertical asymptote is over here at 4, right here. And then I'm going to run out of space here as well as time on this problem. What I'll probably end up doing here is erasing this part, going back to it because I didn't leave enough space on the right-hand side, and finishing this in the next video. Alright, so I need to find the second derivative is the next thing I want to do, and I'm going to try to squeeze that in right here. So I'm going to have to do it from right here. Bottom times derivative of the top minus the top times derivative of the bottom, which would be 2 and then x minus 4. All over bottom squared, which would now make that say x minus 4 to the 4th power. Now, one of the things you guys will get more used to is that you have two terms here, and when we have these huge quantities, we're not going to want to multiply this stuff all out. What we're going to want to do is look for common factors. And so I've done this in another problem where I've simplified. I'm going to take out an x minus 4 everywhere. So I'll change this to be x minus 4 to the 3rd. I'll eliminate an x minus 4 here, and I'll eliminate an x minus 4 here. I can do that because I have one term here, another term here, and then a term down below, and each of the terms have an x minus 4. So what that leaves me with is an x minus 4 times a 2x minus 8 minus, I have this 2 times this, so I have minus 2x squared minus 8x plus 12 all over x minus 4 to the 3rd power. Now it looks like this isn't going to simplify very well, but it actually does. I end up on top when I FOIL this 2x squared, a minus 8, and a minus 8 is minus 16x, and a positive 32. Minus 2x squared plus 8x minus 24 all over x minus 4 cubed. What happens then is my x squareds cancel. I have a mistake right here. You guys weren't there to yell at me. This should have been a 16. I knew that these were supposed to cancel. These cancel now. And then I have 32 and negative 24, which gives me an 8. 8 over x minus 4 cubed. So you see me make some mistakes here. On the bottom is my only critical number. My only critical number then is 4 for the second derivative. I called it a critical number. Possible point of inflection is what I should have been calling that. So when I test for concavity, when I plug in 5, I end up with a positive value, and when I plug in 3, I end up with a negative value. So I know where it's concave up and concave down. So I haven't done each of these things, but due to time and the length of these videos, I'm going to go ahead and start sketching this. I have a vertical asymptote at x equals 4. I have a slant asymptote at x minus 2, y equals x minus 2, so that would be here, up 1 over 1, up 1 over 1, up 1 over 1. There's my slant asymptote. And then I know that it is concave up and concave down. Is concave up over here and concave down over here. So basically I know it's going to squeeze in between these parts. I know that there's max is a max at 2 and a min here at 6, and I did not find those values. You really should find those values. You would find those values by plugging those values back in up here and plugging them in for the x portion, and that would give you, I will just go ahead and tell you, those max value is 2, -2, and the minimum value is 6, 6. Because of the length of these videos, please feel free to ask me any questions that you guys need to during class.